Hello, everyone. My name is Álvaro Prieto. I will be doing question number one. Number one says an object is moving following the law x1 of t, which equals 100 plus 5t. And then object 2 is moving following the law x2 of t, that equals 3 meters plus t squared. Question 1 says, at what time object 2 and object 1 have the same x? So we have here, we put the first equation equal to the second equation, because we have to see at what time have the same x. Both of them have the same x, so both of them have to be equal to each other. So here we do some algebra. We get this step goes from this to this. Then we do the quadratic formula. At the end we get these two values. The only one we could get is the positive value, since we need the same x. Now question 2 says, at what time the velocity of object 2 is equal as the velocity of object 1 as the velocity of object 1. So we do this part. We get from this to this, and then we get 2.5 seconds. That's how much the velocity of object 2 is equal to object 1. It says equal to object 1. Then we draw 3 different graphs. One for the object 1. Object 1 is positive, as we could see here in this equation. It's positive slope 5t. It's a constant slope, so when it's constant, the acceleration is 0. Now for equation 2, we have 3 plus t squared. T squared, so it's a parabola, so it's going up positive. It is up positive, is positive slope. Here's, I meant positive and constant, and since it's positive, it's constant, the acceleration. That's for question 1. Okay, now we are in question 2. A particle that starts at the origin x equals 0 with a velocity as shown in the picture as I units. The displacement measured in meters of the particle after 5 seconds is. So in here we see 10 and 2. This is the y-axis, so the meter per second. And here we have time. So between 10 and 2 we have 8 over here, which makes a right triangle over here. Okay. We use the slope of the graph, b minus t, b to t, which is this. We use a 4 seconds because, as we said, 8. We found 8 because 10 minus 2 is 8. And then ended up in the 4. So you will have to divide 8 by 4, which is 2 meters per second squared. We use this formula for the next step to find the polynomial, which illustrates another version of the graph. With the steps, we plug in the steps that we with the given equation. We have the 2, which is the 2 meters per second, 2 again, and then we plug in values 4 and 5. We get these values over here for the x. Then, as we give the 4 and the 5, we add these 2 meters and we get 34, which is answer C. So we have here the next question. It says the picture below at the right shows the velocity for a particle as a function of time. Which graph represents x of t? So we are given this equation, and we're trying to find the graph that represents as x of t of our given graph. So as you could see, this negative slope is going down. There's a point of intersection with the x values of, in this case, the t values, and we could see the arrows going down, decreasing the values until it gets to this point, and then so we look at A. A in this case could not be, because the point changes exponentially. It has to be quadratic. So this cannot be. We discard A. B, on the other hand, does not intersect T, and it's a positive parabola, so no. C, on the other hand, will intersect because it's infinity. It's a negative parabola, which keeps. And then D is constant. E, on the other hand, doesn't have anything to do with the graph shown. Alright, we have this next question. The picture to the right shows the velocity of t of x of a particle, and then which graph represents the acceleration of x at t. Sorry about that noise, it was my dog, if you heard it. So as the other problem, which was number 1, we said that when the velocity is constant, the acceleration is 0. So in this case, if the velocity is constant over here, constant, the following acceleration should be 0. So it should be in this. Now we follow the next line, and it's positive velocity. Now, positive velocity will be constant acceleration. So it should be constant acceleration in this part, in number 2, in this part 2. Then we follow this line, and then we get constant again. Constant means 0 at the t values. So in this case, it will either be between B and D. The others don't count because remember, when the velocity is constant, the acceleration is 0. So here I don't see anything. Here I do. Oh, there should be 2. Sorry. Here no, here no. Yes and yes. Yes and no. So this no. This yes and yes. And this doesn't have anything. So it's between these 2. Now how do we know which one? Of course I already have this answer, but we should look at this first. So as we said in 2, the velocity is increasing. So when the velocity is increasing, the velocity is constant. Here it is increasing, so it cannot be. This is constant, so it's D. Okay, we're in the second question. The next question. It says a particle is moving on the x-axis where velocity of x is shown on the picture as a function of time. And it says all units are on SI system. And what is the displacement in meters after 2 seconds? Okay, so we have this graph given. Okay, so we should find an intermediate value, which is 4. We already have 8. We should find an intermediate value of 4 and intermediate value of 2. So we could visually see how this line increases, the slope increases, because it's a positive slope. Okay, so we have the t value and the v value. So we multiply both and divide by 2. Divide by 2, why? Because we're moving 2 up. I'm sorry, 2 to the right. So it will be 8, 2 times 4 over 2, which is 8 to the 2, which is 4. So the answer is 4. As we look over here, we have the V0. So we have, okay, so we have V final, the velocity final, 8 meters, time final, 4 meters. Then is the change of V divided by the change of T, which is 2 meters. Then we get this formula right here. And we do the velocity, starting velocity plus acceleration. So acceleration of T. So the starting velocity is, of course, is 0. And then plus 2 because we got 2 from here. This is 8. So 2t. T is 2. As we said, as we looked at in the question. So it should be 4. Okay, we're in the next question. So we're giving a triangle, and we have to find the vector sum. The vector sum is vector A plus vector C plus vector vector A plus vector B plus vector C equals what? So we're gonna name the big vector S. So we're gonna find this gap right here. So we're gonna start in this position, the highest position, which is the tail of A. So from the tail of A, we move to the right, so to the west direction, and then from the head of the neo goes down one, as you can see right here. So 2 to the west direction and 1 south, so 2i minus 1j. I say in this case because west and south. So the answer would be C. Okay, we have a similar problem. It says, what is the correct expression for the vector on this figure and why? Okay. So we're giving only this vector. So again, we start with the tail of this. So it's gonna be 1, 2, 3, negative. And then we continue from the tail of the new one, which is 1, 2. So 1, 2, 3, negative, south, and 1, 2, west. So the answer would be D. Okay, this is the next question. If H vector equals 5i plus 2k and M vector equals negative 4j plus 3k, find and draw 3h minus 2m. And it says, please write your answer as A or B or C. A, B, C, D, or E. Okay. So we get H and we get M. We get those two. And the question is 3H. What is 3H minus 2M? So we get from H, we get this equation times 3 minus this equation times 2. We get this is equal to this. Then this is distributed, getting this. Now we do algebra, we combine like terms, and we're gonna end up with 5i plus 8j. Now I don't know if there was a mistake with this question, but the answer should be D, but it has a negative. So D or E? E, D or E. This is the next question. It says vector V has a magnitude of 60 centimeters per second. What is the expression for this vector using units of meters per second? Okay, so we have this graph right here. We have X and we have Y. We have this angle 150 and 2 here. But 90 plus 90, since it's 90 and 90, it will be 180. The missing angle is 30, since 150 plus 30 is 180. Okay, now that we know that, we get this equation. Vector of A equals the magnitude of vector A cosine of I plus the magnitude of A sine of J. So it will be the magnitude of A, since it was given, it was 60 centimeters per second. To be able to simplify the most that we can, we times it times the kilometers and then the meters per second. And we end up with 7 times 10 to the negative 1 meters per second, which is, in other words, 0.6. Then we put that value again into the equation, the original equation, and it's 0.6 cosine of 150, the angle, the main angle of I, plus 0.6 sine of 150j. So we simplify, it's negative 0.6 cosine of 30 plus 0.6 sine of 30. We do the trigonometry. We look at the unit circle, and we end up with 0.3 times 3 squared, square root of 3, my bad, I plus 0.3 j. So the answer will be A. Alright, next question. It says, given vectors A, B shown on the picture, draw the vector C that satisfies the equation. So vector of A minus 2B plus C equals 0. Alright, so we have vector A, vector C. So in this one, this one will be A plus B. Now we know that the parallel opposites will be A plus B plus negative A plus B. So in other words, you could use the negative 2, or you could use the negative 2, which is this method, but I prefer this method, which is isolate C. By isolating C, you move all of this to the right side. So it will be C equals negative A minus 2B. So this negative, it will distribute both. So it will be C equals 2B minus A. That's the proven method. Alright, so we have the next question. You launch a stone vertically up on the presence of the gravitational field of the Earth, which gravity equals negative 10 meters per second squared. If the initial speed was 20 meters per second, after 3 seconds, what will be the speed of the stone, and in what direction will it move? Okay, so we know A, which is negative 10 meters per second. Why do we know that? A is basically G, gravity. And the initial speed, which is 20 meters per second. Time, it says 3 seconds. So we use the formula BFY minus B initial minus G of T. G of T is gravity times time. B of Y is basically the 20 meters per second. 20 meters per second minus 10 times 3 will be 20 minus 30, which give us negative 10 meters per second. That's what will be C. And then we have the last question. It says, a snowball rolls off a barn roof that slopes downward at an angle of 40 degrees. The edge of the roof is 14 meters above the ground, and the snowball has a speed of 7 meters per second as it rolls off the roof. Ignore air resistance. How far from the edge of the barn does the snowball strike the ground if it doesn't strike anything else while falling? So we have here our problem. AY of negative 10 meters per second squared on AX of 0, which is acceleration of 0. 7 sine of 40, which is the initial velocity of Y. And the initial velocity of X, 7 meters per second. We get the formula Vy of t equals V of 0 b initial plus b of a of t, my bad, which we get negative 7 sine 40 minus 10t. We look at this going down linearly by this part right here, and this part is going down, it's going down, it's going down, 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 down. And we look at the conditions.